Hello everyone, I hope that you all are doing well. Today we solve a very nice question. This question is asked in GATE Mathematics 2017. Okay, and this question is from the functional analysis part and mainly from the Hanh-Banach theorem part. Okay, and here the vector space or non-linear space is given R square. It is a non-linear space. Okay, normed space. And what is the norm defined on it? Norm is defined xy. Norm of xy is defined in this way: x mod plus y mod. Okay, and capital X is a subspace of R square, and capital X is defined in this way: xy ordered pair belongs to R square such that x equal to y. Means geometrically R square is the whole plane and capital X is the line passing through the origin y equal to x. Okay, this is the line. And what Hanh-Banach theorem says? Hanh-Banach theorem says that if x is subspace of R square and if f is a linear functional which maps from x to linear functional means which maps from x to the scalar field. In our here scalar field is R. Okay, then f can be extended to whole R square, and condition is that x can be extended to the whole R square. Let the extension linear map is G. What is the condition on G? G is the extension, means G maps from R square to whole R square to R such that G restricted to x should equal to f and norm of G should equal with norm of f. Then it is called Hanh-Banach extension. Okay, these two conditions will be used to solve our problem. In our problem, what are given? F, how f is defined? F is defined f of xy, f of x comma y equal to 3x, but in our case f is defined on x means in x is equal to y. In the space x is defined in which way? X equal to y. So it is nothing but f of x comma x equal to 3x. Okay, on x. Okay, and G is defined in question. How G is defined? G is defined alpha x plus beta y. G is defined in this way: alpha x plus beta y, and asking about what is the difference between alpha minus beta, means we have to explicitly calculate what the value of alpha and the value of beta. Okay, then only we can calculate the difference between alpha and beta. Okay, or okay, and here G is defined gxy equal to alpha x plus beta y. Our target is to calculate alpha and beta. Okay, to calculate these two things we will use these two conditions. Condition 1 is this one and condition 2 is this one, is condition 2. Okay, first use the condition 1. From condition 1 in particular we know that, okay, from condition 1 we will get what? G restricted to x equal to f means G of xx should equal with f of xx. Okay, this implies G of xx is what? Alpha x plus beta x should equal with what? 3x. This implies alpha plus beta equal to 3. So from this information, from this property 1 we got one equation, and from property 2 we will to use property 2. First of all we have to know what is the value of f norm. Okay, what is the standard definition of f norm? F norm is defined in this way: norm of f is nothing but supremum of x belongs to space in which space it is defined, fx modulus, here not x, here our order pair f of xx, f of xx divided by norm of xx. But in general we write y, but in the space x y is equal with x. Okay, means in general we write f of xy divided by order pair xy, order pair xy modulus, but in the space x y is equal with x, so it is xx. Okay, xx. So what is the norm is supremum of x belongs to capital X, f of what is the value of f of xx? It is 3x, so it gives 3x mod. Okay, and norm is defined, what is the norm of in the normal space? In nothing but x norm plus y norm, but here both are same, so it gives x mod plus x mod, so it is nothing but twice of x mod. Okay, twice of x mod, so x mod cancel out, so it gives 3 by 2. Okay, so norm of f is 3 by 2. Okay, but we will use the condition 2, g norm equal to f norm. From that we got that g norm which is equal to f norm from condition 2, which is equal to 3 by 2. Okay, but in the left side if we apply the definition of the norm of g norm, if we will apply in the previous calculation for the f norm, in the similar way if we will apply the definition of norm on g, we will get supremum of x belongs to R square, because g is defined on the whole space but f is defined in the capital space X, but our g is defined in the whole space. Okay, so it gives g x y mod divided by xy order pair modulus. Okay, so it gives what? It gives supremum x belongs to R square, and gxy is defined alpha x plus beta y divided by xy, and the norm of order pair xy is what? Norm of the order pair xy is x mod plus y mod, so it can be written as less than equal to supremum of x belongs to R square, it gives a maximum of, if we take out the maximum of alpha mod, or what we first of all we have to apply the triangle inequality, x alpha mod x mod plus beta mod y mod, this comes from the triangle inequality. Okay, it gives x mod plus y mod. Okay, and then we can take out the supremum of alpha mod plus beta mod, then it gives maximum of alpha mod comma beta mod, and supremum of, and it was not x belongs to, it is the order pair xy belongs to R square. Okay, xy, it is y and it is xy. Okay, maximum of x comma y belongs to R square, it gives what? If we take out the maximum, so it gives x mod plus y mod in the denominator also same, x mod plus y mod, so it cancel out denominator, it gives the maximum of alpha mod comma beta mod, so we get the upper bound of g norm. Okay, and to show g norm equal to this, we have to calculate the lower bound also. Okay, and to calculate the lower bound, we know g norm equal to what? If we again apply the definition, maximum of x comma y belongs to R square gxy divided by x comma y order pair modulus, and this modulus and norm, this one. Okay, this implies that it is greater than equal to for in the particular case, if we put x equal to g o g 1 0, x equal to 1 and y equal to 0, divided by 1 0 norm. Okay, or also, okay, if you calculate this one, what we will get? It gives g of 1 0 is alpha times 1 plus beta times 0 divided by it gives the 1 mod plus 0 mod. Okay, so it gives it is modulus. Okay, alpha modulus divided by 1. So we got g norm greater than equal to alpha mod. Similarly g norm greater than equal to g of 0 1 modulus divided by 0 1 norm. From this we will get it is greater than equal to beta mod, and if we denote it star and it double star, from star and double star, from star and double star, we get what? From star and double star we can conclude that g norm greater than equal to maximum of alpha mod comma beta mod. Okay, let it write equation B. Okay, and equation A is what? Equation A is your this one A. Okay, A, from A we get g norm less than equal to maximum alpha mod comma beta mod, and from B we get g mod greater than equal to a maximum alpha mod beta mod. So g norm is equal to maximum of alpha mod comma beta mod. But in the previous calculation we know that g norm is equal to f norm, which is equal to 3 by 2. So from this we conclude that maximum of alpha mod comma beta mod is equal to 3 by 2, and let it write equation C. Okay, but we also know that alpha plus beta equal to 3. This one from 1 we will get alpha plus beta equal to 3. Okay, if we look this equation C, maximum of two number is equal to 3 by 2 means either alpha mod equal to 3 by 2 or beta mod equal to 3 by 2. These are the two conditions. Case 1, let us discuss separately these two cases. Case 1, alpha mod equal to 3 by 2. Then what are the possible values of alpha beta? Alpha equal to 3 by 2 or minus 3 by 2. Okay, if alpha equal to 3 by 2, beta will get what? Beta will get 3 by 2, because alpha plus beta equal to 3. So should beta should gives 3 by 2, and if alpha equal to minus 3 by 2, beta is equal to 3 plus 3 by 2, and which is beta. If you calculate beta mod is larger than 3 by 2. Okay, but in our case we have taken the alpha mod equal to 3 by 2. Alpha mod is what? Alpha mod is the maximum of this, but here we are getting greater than 3 by 2 beta mod. This is contradicting, because in our case 1, if we look case 1, we have taken alpha mod equal to 3 by 2 or beta mod equal to 3 by 2, and this is the what is it? This is the maximum of alpha mod comma beta mod. In our case 1 we have taken this maximum of alpha mod comma beta mod, which is equal to alpha mod, because maximum is equal to 3 by 2, but here we are getting beta mod is equal to 3 by 2, strictly greater than 3 by 2, because 3 plus 3 by 2, this quantity is greater than 3 by 2, but in our from starting we have taken that maximum of these two quantities should be equal to 3 by 2. It should not be greater than 3 by 2, but we are getting greater than 3 by 2. So this case is not possible. So we get alpha mod equal to 3 by 2 comma and beta mod equal to 3 by 2. And if we similarly calculate case 2, if we consider case 2 also, for beta mod equal to 3 by 2, in that case also we will get one case contradiction and one case is okay, which from these things we will get alpha equal to beta equal to 3 by 2. So in the what is the question, in question what is asking, what is the value of alpha minus beta? So we are getting alpha equal to beta equal to 3 by 2. So what is the difference? Alpha minus beta is equal to 0. So this is the correct answer. I hope that you all understood it very well. Thank you all.